Hello everyone, welcome to my channel. In this video, we'll be learning how to calculate the deflection of the subframe system at a certain point and the total internal energy of the system. Please don't forget to like, comment, and subscribe to stay updated for more civil engineering tutorials. Now, let's start step by step in simple way. Our problem is to determine the deflection of the subframe system at point A. This is point A, point B, point C of the system. We are required to calculate or to determine the deflection or displacement at point A and the total internal energy of the system. In order to determine the deflection is obtained by taking the integral for moment due to applied load, this one, and this one. This is the uniform distributed load, and this one a point load times moment due to unit load over EI, stiffness of the material. And the total internal energy is obtained by taking the product of moment due to applied load times the moment due to applied load over 2 EI. So, in order to calculate the moment due to applied load and the moment due to unit load, we suppose to cut section at a certain distance. Let's say at a known distance x. Let's say cut section at this one. Let's say this is section 1, and this one will be section 2. So this system, to calculate the deflection from point A, we'll have two sections, section 1 and section 2. So in order to calculate the deflection at point A, we shall consider deflection section 1 and section 2. So let's consider section 1. Section 1. Section 1 will be in this way. This was 20 kilonewton per meter. This was point load 10 kilonewton. This is point A. This is normal axis, shear force at distance x. This is distance x at distance x. We have cut in a section at distance x. This is normal axis, and this is internal bending moment at x. Therefore, in order to calculate or to obtain the moment at distance x, we take the summation of moment at x is equal to 0. Always clockwise direction will be positive and clockwise direction will be negative. In this problem, clockwise direction you have, this is anti-clockwise direction, so it will be negative. Mx plus 20 will be clockwise direction, will rotate in this way, clockwise direction. So to obtain here will be 20 times its distance x times perpendicular distance from the point load here up to to this point. So it will be x over 2 plus, this will be clockwise direction, that's why we write positive. 10 times perpendicular distance times x, it will be 10x is equal to 0. Our equation will be, this is moment due to applied load at point x. Moment due to applied load at point x. So it will be 10x plus 10x square. This is moment due to applied at point x. So the next step is to find the moment due to unit load. In order to obtain the moment due to unit load, we remove the applied load and introduce unit load at point A. So we say remove unit load, applied load and introduce unit load at A. So it will be in this way. This is unit load. This is shear force at X, normal force, moment due to unit load. This is a known distance x. So we take summation of moment is equal to 0. All clockwise direction positive and clockwise direction negative. So this will be in anti-clockwise direction, so it will be negative mx plus, this is clockwise direction, unit load times is perpendicular distance 1 times x is equal to 0. So mx it will be equal to x. So the deflection, let's say this is deflection 1 for section 1:1. So it will be integral from 0 to a certain distance, integral of due to moment due to applied load times moment due to unit load over EI dx. Therefore, deflection will be 0 from 0 to we take the distance from this point to this one. So its distance is 6 meter. From 0 to 6. Moment due to applied load is 10x plus 10x square over times moment due to unit load is x over EI. So the deflection at this point will be, when we integrate this equation, it will be 10x cube over 3 plus 10x, this is 10x square, when integrate will be 10x cube over 3. This will be 10x cube, when we integrate will be 10x power 4 over 4 over 1 EI from 0 to 6. Okay, let's calculate by using our calculator. 10 power 3 fraction 3 plus 10 over power 4 fraction 4. Calculate 26. It will be 3960 over EI. This is deflection for section 1.1. So let's calculate internal energy. Internal energy at section 1.1 it will be integral from 0 to L and force moment due to applied load times moment due to applied load over 2EI. Internal energy for section 1.1, moment due to applied load is this one. So it will be from 0 to 6, 10x plus 10x square times 10x plus 10x square over 2EI dx. So it will be, when we multiply this one, it will be 100 x square plus 200 x cube plus 100 x power 4 over 2EI. When we integrate this one, it will be here, when we simplify by 2, it will be 50, 150. So this one, it will be, when we integrate, it will be 50x cube over 3 plus 100 x power 4 over 4 plus 50x power 5 over 5 over 1EI from 0 to 6. So our product will be 50x power 3. It will be this one. Over EI. This is Joule. Since a Joule is a unit of energy. This is deflection. Its a unit is meter. Okay, now consider for section 2.2. Section 2.2. Section 2.2. It will be in this way. Section 2.2. It will be in this way. This is normal axis shear force, moment due to applied load at x. This is distance from a known distance x. This is 60 meters from this one to this one to this point A, 60 meters. From this point, when you cut section at this point, so it will be at a known distance. If we have cut in section at this point, at a known distance x, let's say from this point to this point is a known distance x. So from this point to this point is x, and from this point to this point was 60 meters, this one. So in order to obtain the moment at this point, we take summation of a moment at x is equal to 0. So clockwise direction will be positive and clockwise direction will be negative. here was horizontal force, which was 10 kilonewton. This one was 20 kilonewton per meter. This one was 10 kilonewton. So we take summation of moment at this point. Here we're having negative mx since it is an anti-clockwise direction, plus this one, it moves in clockwise direction. It will be 10 times x plus 20 times 6 times its perpendicular distance from this point to this point. It will be 3 plus 10 times its perpendicular distance is 6 meters is equal to 0. Moment due to applied load at point x, it will be equal to 10x plus it will be 420. This is the moment due to applied load at point at this point. Now, in order to obtain the moment due to unit load, we remove the applied load and introduce unit load at point A. So, after removing the applied load, it will be in this way. It will be unit load after removing all applied load. And introduce unit load at point A. This is unit load at point A. Here, this is distance x. This is normal force at point x, shear force at point x. From this point to this point was 6 meters. This diagram shows only unit load at point A. This is point A, point B. Now, in order to obtain this is moment due to unit load at point x. So, in order to obtain the moment due to unit load at this point, we take summation of moment at point x is equal to 0. So, it will be, since it in clockwise direction, it will be negative plus this times force times this one, it will be 1 times 6 is equal to 0. Moment at point x, it will be 6. This is moment due to unit load. Therefore, in order to obtain the deflection at section 2, it will be moment due to applied load times moment due to unit load over EI. Integral from 0 to L dx. So deflection it will be from 0 to 6. From 0 to 6 means that from this point to this point, its distance is 6 meters. That's why we integrate from 0. This is distance we have assumed the distance from this point to this point is a known distance x. So it's fine, it will be from this point, which is 0, up to this distance, which is 6 meters. Okay? Moment due to applied load was 10x plus this one times moment due to unit load was 6 over EI dx. Moment due to its deflection, it will be, let's integrate this one. So when we multiply this one, it will be this one times 6 here, 20 over EI from 0 to 6 dx. So its deflection, it will be When you integrate this one, it will be 60 x squared over 2 plus 25 20 x over ei. We have integrated from 0 to 6. Its deflection will be this one over ei. This is deflection, so it's a 70 meter. It's a 70 meter. Okay, let's calculate the intensity for section 2.2. Intensity at section 2.2, it will be integral from 0 to distance moment due to applied load times moment due to applied load over 2ei dx. So it will be 0 from 0 to 6. Moment due to applied load was 10x plus 120 times this one, 10x plus 420 over 2ei dx. When you multiply this one, it will be from 0 to 6. It will be 100 x squared plus 20 times, it will be 8400 x times over ei over 2ei. So internal energy, total energy, it will be, when we integrate this one, before integrating we may simplify this one. Here we get 50. So when we integrate, it will be 50 here x power 3 over 3 plus 4200 x squared over 2 plus 8200 x from 0 to 6. Let's substitute this one. Plus 21 calculate 26, it will be equal to 608 over ei joules. So our problem, we were required to calculate the deflection at point A. The deflection at point A it will be deflection for section 1 plus deflection for section 2. So deflection at point A, deflection for section 1 was 3960 over ei plus deflection for section 2 was this one over ei. Deflection at point A, 3960 plus 16200. Deflection for at point A it will be 20160 over EI meter. This is deflection at point A. Okay, now calculate therefore deflection. Deflection at A, it will be 20160 over I meter. Internal energy, total internal energy. Total internal energy at total internal energy of the system, it will be energy for section 1 plus energy for section 2. Total energy, it will be energy for section 1 was 113,760 over EI plus energy for section 2 was 608,400 over EI. Total energy 113,760 plus 608,400. Our product is 722,160 EI joules. Therefore, the total energy of the subframe system is 722,160 over EI joules. All of those are the products, are the total deflection at point A and the total internal energy of the system. Thank you for watching this video. Please don't forget to like, comment and subscribe to stay updated for more civil engineering tutorials. Thank you.